Okay, for this lesson, we're going to be solving quadratic equations by graphing. In order to solve a quadratic equation by graphing, you need to find the x-intercepts. So to warm up, let's practice graphing the function, labeling the vertex and axis of symmetry, and refer to the graphing flowchart to jog our memory if needed. So just looking at this first function here, this function is written in standard form. So if I go over here to the factoring flowchart, I'm looking for where it says standard form, and I see standard form right here. So the first thing I want to do is find the axis of symmetry, which I use negative b over 2a to do that. Okay, so let's find the axis of symmetry. We're going to use x equals negative b over 2a. A is equal to 1, b is equal to negative 8, and c is equivalent to 12. Okay, so I'm going to do opposite b. So opposite of negative 8 will end up being a positive 8 over 2a, and a is 1. Let's simplify that. We end up with x equals 8 over 2, or the axis of symmetry would be x equals 4. So let's go ahead and graph the axis of symmetry. 1, 2, 3, 4. Okay, that's where the axis of symmetry would be. We'll label it. And now what's my next step? Well, if I go here, it looks like my next step is to find the vertex, which I use negative b over 2a, f of negative b over 2a. All we're going to do is substitute the x value from the axis of symmetry into the original equation and solve. So if I'm identifying my vertex, we know that the x value of the vertex is the same as the axis of symmetry. And all I'm going to do in order to get the y output is I'm going to plug 4 into this original function up here. So we'll have 4 squared minus 8 times 4 plus 12. Okay. 4 squared, I know that 4 squared is 16. Minus 8 times 4. 8 times 4 is 32. Plus 12. So we get negative 16 plus 12, or negative 4. Okay, so I'm going to put that as my y value and plot it. All right, what's next? Next thing I want to do is find my y-intercept. We're going to substitute 0 in for x and simplify. Solve for y. So for my y-intercept, I'm going to plug in 0 for x. So I have 0 squared minus 8 times 0 plus 12. So if I simplify, that really just becomes 12. So I have a y-intercept at 0, 12. And you can see that we kind of run off of the graph here. Because I run off the graph with 0, 12, maybe let's use intervals of 2 from my y-axis. So if I'm going to do intervals of 2, we'd have negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Okay, this would be 2, 4, 6, 8, 10, 12, 14. Let me replot my vertex. My vertex was at 4, negative 4. 1, 2, 3, 4, and then negative 4 was going to be right here. My y-intercept 0, 12, so that's right here. We can see that that y-intercept is a distance of 1, 2, 3, 4 away from the axis of symmetry. So I want to go that same distance over here. 1, 2, 3, 4. We're going to be a little bit off the graph. That's okay. So it'll be somewhere over here. Oops. And there we go. Okay. Let's go ahead and go over this guy. This is in vertex form, which I like even better because it's easy to identify our vertex, right? If something's in vertex form, we can use an XY chart to transform the parent points. Okay, we can also use this flow chart to help us, but really I prefer the transformation chart as opposed to doing it this way. Okay, I much prefer to use the transformation chart. So what I'm going to do is just set up my XY chart. Parent points are normally negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. We can see that there's been a right 2 shift. So I add 2 to the x values, and minus 6 shift down. So shifting the y values down 6, we're going to end up with 0, 1, 2, 3, 4 for our x values, and -2, -5, -6, -5, -2 for our y values. Okay, so let me go ahead and plot that. 0, -2, 1, -5, 2, -6, 3, -5, and 4, -2. Okay, there we go. That's how I'd graph my parabola. You can still see that the axis of symmetry would go right through the vertex. I'll do that with a line, actually, instead. We'll go right through that vertex. So you can see the axis of symmetry would be at x equals 2. Okay. And my vertex, in this case, is the point 2, -6 because of that right 2, down 6 shift. All right, so now that we reviewed graphing, let's go ahead and actually get into solving quadratic equations. It tells us that a quadratic equation is an equation that can be written in standard form using ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0. A root of an equation is just the same thing as saying that it's a solution of the equation. We can use the terms root, solution, 0, x-intercept interchangeably. So that's important to know that they all mean the same thing. Root, solution, 0, x-intercept. We're going to use those interchangeably. Traditionally, you'll see phrases like the solution of an equation, or the root of a polynomial, or the 0 of a function. However, all these phrases indicate the x value where the graph crosses the x-axis. Okay, so quadratic equations can have no solutions, one solution, or two real solutions. You can find these solutions by, this is important, graphing, using square roots, factoring. If these methods don't work, you could also use the quadratic formula or completing the square to find solutions. Okay, so in this chapter, we're going to be solving quadratic equations by graphing, using square roots, factoring, completing the square, and quadratic formula. Okay, so CTS, like I said, CTS is going to be completing the square. So core concept, it says by graphing. If we're solving it by graphing, keep in mind that I just need to find the x-intercepts. That's it. If we're using square roots, we want to write the equation in the form u squared equals d. We're going to get to this a little bit later. Okay, so we're not going to focus on this one today. And then by factoring, write the polynomial equation, ax squared plus bx plus c equals 0 in factored form and solve. So we'll talk about that a little bit more today as well. So our goals today is really to go over how to solve by graphing and by factoring. Okay, so here it says solve by graphing. The solutions to a quadratic equation are the x-intercepts. So let's find the roots. Again, what's root synonymous with? A root is the same thing as a solution, as an x-intercept. Okay. And what was the other one? Solution, x-intercept, and 0. Yeah, I can't forget 0. Okay, those are all going to be used interchangeably. So if I want the roots, I just have to figure out where my x-intercepts are. So let's highlight the x-axis. Where does the function cross the x-axis? It crosses the x-axis here and here. So my solutions are going to be -2 and 3 because that's where my x-intercepts are. Okay, notice that this is not the same thing as an ordered pair. I'm just writing a list of x values, and I put the lower x value here and the higher x value there. Okay. What about this one? Where does it cross the x-axis? Crosses the x-axis right here. So -1, 0 is my root or my solution. So I'm just going to put x equals -1 as my answer. It says, how do you find the x-intercept of any function? Where do I plug in 0? Plug in 0 for what? Y. And solve for x. Okay, so I'd be plugging in 0 for y, and I'd be solving for x. So my x-intercepts would be x comma 0. Let's talk a little bit more about finding x-intercepts. There's something called the zero product property of equality that says for any real number a and b, if a, b is equal to 0, then either a is 0 or b is 0 or both would be 0. So let me just show you an example. If I want a product that gives me 0 where I have a number times a number equals 0, what does one of those numbers have to be? Like if I put 2 times something equals 0, what would that something have to be? Well, in order to get a product of 0, one of the numbers has to be 0. Okay, so let's keep that in mind. Down here, I have 2 numbers or expressions multiplied together that gives me 0. So one of these has to equal 0 or both have to be 0. Like if x plus 2 was 0, we'd get 0 times x minus 6 equals 0. Is that a true statement? Yes, that would work because 0 times anything would end up being 0. Another option is that we could make x minus 6 equal to 0, because what would that look like? We would have x plus 2, and then x minus 6 would be 0. Does that make a true statement? Yeah, because again, something times 0 would be 0. So one of those options have to be true, okay, or both would have to be true. Here, if I solve for x, we would get that x would be -2. Here, if I add 6 to both sides, we would get that x is 6. Imagine plugging it back in. If I plugged in -2 for x, would it give you a product of 0? Yeah, it would. Or if I plugged in 6 for x, would it give me a product equal to 0? Well, yeah, 6 minus 6 would be 0. All right. Okay, so with that in mind, it says to solve a quadratic equation or to find the x-intercept using basic factoring, we have to complete these 3 steps. First, make sure the equation is in descending order and set equal to 0. We're going to factor one side and then set each factor equal to 0 and solve. So here we're going to solve each equation by graphing. Again, as soon as I see solve each equation, I'm instantly thinking find the x-intercepts. Okay. So let's look at the first one. Part A is written in standard form. So for standard form, let me go ahead and erase all of this stuff. For standard form, let's go through our steps together. We're first going to find the axis of symmetry. So axis of symmetry is x equals opposite b over 2a. Here a is 1, b is -1, c is -6. So if I do opposite of b, it would be +1 over 2a, and a is 1. So we get that the axis of symmetry is x equals 1/2. Okay, so I'm going to go ahead and graph that. Okay. Then to get my vertex, what do I need to do? I need to substitute the x value from the axis of symmetry into the original equation and solve. Okay, it's going to be -b over 2a, comma f of -b over 2a. So I know that my x value of my vertex is 1/2, and I just have to plug in 1/2 into my original function. So I'm using this function up here. So I'll get 1/2 squared minus 1/2 minus 6. And simplify. We'll get 1/4 minus 1/2 minus 6. Get a common denominator. Let's use a denominator of 4. 1/2 is equal to 2/4. And then what would 6 times 4 be? 6 times 4 would be 24. Isn't 24 over 4? Doesn't that reduce to 6? Okay, all this can be done in your calculator, but I'm just using this as a fraction review. 1 minus 2 minus 24 would give me negative 25 over 4. And I do not think that can be reduced at all. 25 and 4 don't have any common factors other than 1. So I'm going to put negative 25 over 4. Okay, which is really, how many times does 4 go into 25? 4 goes into 25 6 times. And then I'd have a remainder of 1. Okay, so I'm going to graph this at 1/2 and then negative 6 1/4. So somewhere down here. Okay, and we've already got our axis of symmetry drawn, so now what? I'm going to do the y-intercept by substituting in 0 for x. Y-intercept. If I substitute in 0 for x, what would I get? What is 0 squared minus 0 minus 6? That would be 0, negative 6. So all those points are pretty close together. So I can kind of guess where my x-intercepts are going to be. So right now it kind of looks like negative 2 and 3. But again, that's just an approximation. How can I find my x-intercepts? Well, let's go back up here and let's remember what it said. It said to solve a quadratic equation or to find the x-intercepts, use factoring. Make sure it's set equal to 0, factor the one side, and set each factor equal to 0 and solve. Okay, because remember, in order to get an x-intercept, we plugged in 0 for y, and now we have to solve for x. Okay, so if I'm going to factor this, what times what is x squared? X times x. What times what would multiply to give me negative 6, but add to give me negative 1? What are some things that multiply to give you 6? 1 and 3, or 1 and 3. 1 and 6. 2 and 3. What would work to get you negative 1 in the middle? The 2 and 3. Right, where the bigger number 3 would have to be negative. Right, my outers would be negative 3x and my inners would be 2x. And that would get me to the negative 1x in the middle. So that looks good. Set each factor equal to 0. And we get negative 2. And here when I add 3 to both sides, I would get 3, right? We're just solving for x. So those are my x-intercepts. I should have an x-intercept at negative 2, 0, which that's exactly what I guessed. And it looks like I have an x-intercept at 3, which is actually, that's what we predicted. Okay, so those are going to be your two solutions. My solutions are going to be negative 2, 0 and 3, 0. Okay. It's much faster to check your work on your graphing calculator. Okay, if I was going to do a solve by graphing equation, I would use my graphing calculator to help me quickly get my solutions. Over here, this is not set equal to 0 right now. Let's start by setting it equal to 0. I'm going to add 2x squared to both sides. I really want my x squared term to be positive. I don't like working with negative leading coefficients in front of x squared. Then we'll add 2 to both sides. So we'll get 2x squared plus 4x plus 2. All right. So now, again, it's in standard form, so we're going to go through the same process. My axis of symmetry is going to be negative b over 2a. So my a value is 2, my b value is 4, and my c value is 2. X equals opposite b would be negative 4 over 2a. A is 2. So I end up getting x equals negative 1 as my axis of symmetry. For the vertex, we're going to use that same x value, and we have to plug it into our function. So I'm going to plug it in to this function right here. So what do I get? I would get 2 times negative 1 squared plus 4 times negative 1 plus 2. If I square negative 1, I get positive 1. 4 times negative 1 would be negative 4. Okay, so I get 2 minus 4 plus 2. So I think that's 0. Okay, so I get negative 1 comma 0 for my vertex. Then what? Then I need the y-intercept. So I'm going to plug in 0 for x. So again, I'm using this function, 2 times 0 squared plus 4 times 0 plus 2. So I get that my y-intercept is 0, 2. Okay, that looks good. And now let's graph it. I have an axis of symmetry at x equals negative 1. Okay, so this is my axis of symmetry. My vertex is at negative 1, 0. And my y-intercept is at 0, 2. Okay, it's 1 unit away from the axis of symmetry, so I'm going to go 1 unit away on the other side as well to get a mirror point. And there we go. I really don't even need to factor on this example to see where my graph crosses the x-axis. It would just be right here, right? What is that point? I'm just going to highlight the 1 point actually. That point is negative 1, 0. So I would instantly say that my solution is going to be negative 1. But let's go ahead and let's factor it anyway, just to confirm. Okay, I'm using this function. We're finding the x-intercept, so it looks like we already plugged in 0 for y. We have 0 equals 2x squared plus 4x plus 2. What's always the first thing you want to look for whenever you start a factoring problem? GCF. What are all of the terms divisible by? 2. If I divide the first term by 2, I get x squared. The second term divided by 2 would be 2x. And the last term divided by 2 would be 1. This is a trinomial. Let's do our trinomial guess and check factoring. What times what is x squared? It's going to be x times x. And what numbers would multiply to give you 1, but sum or add to give you 2? 1 and 1. Because all of those are plus signs for the x squared plus 2x plus 1, I would make these plus signs as well. And you can see if I set each factor equal to 0 to solve, 0 equals 2 is not a true statement, and there's no variable to solve for. But here, when I solve for x, you can see in both instances, I would get that x is negative 1. Okay, so really I just have to write it twice. Right? And again, I can see that x-intercept on my graph as well. So now we get down here where it says finding x-intercepts using the graphing calculator. Again, you can see how tedious it is to graph a function just to get your x-intercepts. It's really not necessary to do that by hand. The quickest way to check your work is just with your calculator. What we're going to do is enter the function into our y equals, press the graph button, which you can see is right up here in the top right-hand corner. And then to accurately calculate our intercepts, we're going to do second calculator trace 0. Remember, 0 is a synonym for root, 0, solution. So if I'm trying to find the solution, or if I'm trying to solve my equation, we're going to, in our calculator, do second calculate or trace and select the 0 option. Okay, so let me show you what that looks like. Okay, so let's practice just quickly finding the x-intercepts using the graphing calculator. My first function was this x squared minus x minus 6. We're first going to go to y equals on our graphing calculator. So that's going to be right here. I'm going to press y equals. clear out any equations you already have in there. Okay. You can see right now, even I have some dots in my calculator, and that's from the regression equations we did in the last chapter. So if you have your stat plot turned on, you might even do second y equals and just turn that off just so that our dots are not showing. Okay. But if I go to y equals, and once it's all cleared out, we're going to put our function in there. So again, we're going to use this x squared minus x minus 6 for now. X, we're using this button. I can hit this little up arrow to put in any power I want. So I went ahead and put in squared. Press the over button. Minus x minus 6. Okay, and press graph. Once you press graph, again, graph's in this top right-hand corner, you want to make sure that you have an appropriate window. Just look at the graph I gave you to fill out. Okay, we can see that it goes up to 1, 2, 3, 4, 5, 6, 7, and it goes over to 1, 2, 3, 4, 5, 6, 7. So if you wanted to match that, I could go to my window and I could adjust my x min to -7 and x max to 7. I could adjust my y min to -7 and my y max to 7 if you wanted to perfectly match the graph that you're trying to create. Another way to quickly set the window, and this is the way I like better, is to go to zoom and just go down to zoom standard, because it'll give you a -10 to 10 window. Okay, so -10 to 10, -10 to 10. And that is just a quick way to adjust your window. Okay, once I've hit graph and I've adjusted my window, then I'm going to do second calculate or second trace and calculate the zeros. So I can tell just by looking at this. See how right now it looks like it goes through -2 and 3? Done. But if you want to confirm it, you can go to second trace or calculate. 0, remember, is the same thing as a solution or an x-intercept. And I'm going to start just by arrowing over one of them. See how it's kind of hovering over a 0? Our calculator is asking us, and I'll zoom in, our calculator is asking us to go a little bit to the left of that 0. So with my left arrow, I'm just going to press left, left. And I'm a little bit to the left of it now, so I'll press enter. Now it's asking for you to be a little bit to the right of the 0. So I'm going to put my cursor just back on the 0, and now I want to go a little bit to the right of it. So I'm going to press the right arrow a couple times, and right, right. Then I'll press enter. Now it wants to know if you want it to guess the 0, and you press enter to say yes. And there we go. We have a 0 at -2, 0. See how it gives it to you right down here? All right, we'll have to repeat that process for the other 0. So I'm going to do second trace or second calculate. Go to 0. Arrow over to what 0 you want to calculate. Okay, try to land on top of it. Go a little bit to the left of it. Left, left. Enter. Okay, go back on top of it. Now we're going to go a little bit to the right. Right, right. Press enter. Then we're going to press enter again to get it to guess. There you go. There's our 0. 3, 0. Let's repeat this process again for the second question. For the second question, we're going to use this 2x squared plus 4x plus 2. So I'm going to go back to y equals, clear that out. We'll type in 2x squared, arrow over, plus 4x plus 2. Graph. Okay, I'm not going to mess with the window. So I'll go to second trace or second calculate, a 0. Arrow over where you think the 0 is. Go a little bit to the left of it. Left, 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 left. Enter. Okay, go back to it. Now go a little bit to the right of it. Right, 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 right. Enter. Press enter again to guess. And you can see that we get -1, 0, which is exactly what we found. Okay, so I always use my calculator to check my work. Whenever I'm solving by graphing, you can do it by hand, but it's much more efficient if you use your calculator.